Alright, so let's talk ellipses. Ellipses are just a special type of circle. We could have written our circle up above as an x squared over r squared plus y squared over r squared is equal to 1, like we have up here. The only difference between circles and ellipses is basically it's saying that the radius is going to be a different distance going vertically as it is horizontally. That's really all that's saying. And A is always going to go along with my x value, and B is always going to go along with my y value in these cases. Alright, so again, A is that horizontal stretch from the center, and B is that vertical stretch from the center. In order to graph an ellipse, we have to find the center still. We have to plot one point that is A spaces left and right of the center, and one point that is B spaces up and down from the center. Alright, so we did these a little bit last year. Shouldn't be too horribly terrible. So, I am going to expand my screen out a little bit just to give myself a little bit better graph paper. If you guys need some graph paper, I can always have some in my classroom. Just ask for some, don't feel shy. Alright, so I've got my graph paper. I'm going to assume that if I don't have anything marked up, that each of my individual grids are just going up by 1. So, looking at example 2, problem A, I've got x squared over 25 plus y squared over 36 is equal to 1. This equation is in the form of an ellipse. I look at my top with my x squared, I don't see anything, which means that my x value of my center should be 0. And up top with my y, again, I don't see anything added or subtracted with that y squared, so my y value of that center should be also 0. Alright. Other than that, all I've got to do is try to figure out, okay, how much am I stretching this horizontally? How much am I stretching this vertically? Well, in order to figure out how much I'm stretching it horizontally, well, horizontal distance is going to be my x value, so my horizontal distance is going to be directly underneath my x term. So, right underneath, my a squared in this particular case is 25, which means that a was 5. So that is my horizontal stretch. Alright, and then underneath my y stretch is going to be directly underneath, which is usually b squared. So in this case, b is just 6, which means that I am vertically stretching 6. Alright, from here, all we gotta do is go over and graph it. So I've got my center at 0, 0. I horizontally stretch 5 in each direction. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then vertically stretch 6. So 1, 2, 3, 4, 5, 6. And then down 6. 1, 2, 3, 4, 5, 6. And then connect it the best you can. Alright, I may have cheated. I may have found a tool that lets me draw a circle on here again. They have updated my software in OneNote, so I'm still getting used to that. It's pretty nice, not gonna lie. So, that one wasn't too bad. Let's try the next one. So looking at my next problem, I've got y minus 1 quantity squared over 16 plus x plus 3 quantity squared over 4. This is all equal to 1. I see this plus sign sitting here, which tells me, hey, I've got an ellipse again. Cool, and it's underneath the ellipse section, so I hope that you think it's an ellipse for now. This time, I do see stuff up with my x and my y. Be careful, though, because x stuff still happens with x's, y stuff still happens with y. So, in this particular point, my center is going to be -3 because that is my transformation with my x value, comma, +1. Alright, being very, very careful, a is always with my x, so a squared is directly underneath my x stuff, so a in this case should be 2 because that 4 is a squared. Likewise, b is always going to be underneath my y stuff. So my b squared is currently 16. So b just by itself should be 4. So all in all, let's go graph this. I've got my center at -3, 1. And then I've got A, which is my horizontal stretch, is 2. So 1, 2. 1, 2. And then my B is 4. 1, 2, 3, 4. 1, 2. Oops. Come on. 2, 3, 4. And then I connect the dots the best I can, and I call it a day. Ta-da! We graphed ellipses.